Hi, this is Rogério da Silva here again. So this is section 5 out of 6, so nearly there. So this section we're gonna be talking about primarily about test management. So the test management is something that we're gonna be talking about what the test organization needs to do to prepare for the testing. So the test planning, estimation. We're gonna talk about the test progress, the monitoring and control, the configuration management, the risk and testing, the incident management. So there's loads of important information there. I do hope you been enjoying so far the videos, and let's go, let's do it. So what you will learn on this fifth section of the ISTQB. In this section, we're going to talk about learn to identify risk and its levels and types of risks, the role of test lead, the tester's tasks, learn what test approach means and how to use it, the importance of master test plan, the standard for software testing documentation, IEEE 829, test planning activities, determine the entry and the exit criteria, test estimation, and in the end, test control. Test organization and independence. The effectiveness of finding defects by testing and reviews can be improved by using independent testers. So development staff may participate in testing, especially at the lower levels, but the lack of objectivity often limits the effectiveness. So for large and complex or safety critical projects, it is usually best to have multiple levels of testing, with some or all of the levels done by independent testers. Testing tasks may be done by people in a specific testing role, or may be done by someone in another role, such as a project manager, quality manager, or business and domain expert. So options for independency in a test team include no independent testers, developers testing their own code, which is a low. Independent testers within the development teams, other developers doing the testing, no. Independent test teams or group within the organization. Independent testers from the business organization or user community. Independent tests as specialists for specific test types such as usability tests, security testers, or certification, which involves regulatory testers. Independent testers, outsourced or external to the organization. So as more independent the testers are, is better for the objectivity of the tests. So these benefits of the independent testers include they will see other and different defects and are unbiased. They verify assumptions made during specifications and implementation of the systems, and they bring experience, skills, quality, and standards. And the drawbacks of having independent testers is the isolation from the development team, leading to possible communication problems. They may be seen as a bottleneck or blamed for delays in release. They may not be familiar with the business, projects, or systems, and developers may lose a sense of responsibility for quality. So, task of the test leader and tester. Most test teams consist of two distinct roles, test leader and tester. The activities and tasks performed by people in these two roles depend on the project and the product context, the people in the roles and the organization. So the test leader and the tester, they sometimes they overlap what they do, but they have specific key points that they do, if you see on this comparison here, so the test leader and the tester, they send timely status reports. Test lead and tester, they have flexibility, and the test lead is mainly focuses on assisting in the deliverables and the timely work allocation to testers, and the tester complete the assigned tasks and discuss issues with leads. Now, this is a typical test leader tasks. So the role of the test leader or test manager, test coordinator may be performed by a project manager, a development manager, a quality assurance manager, or the manager of a test group. So typically the test leader plans, monitors and control the testing activities and the tasks described later point. So typical test leader tasks may include write or review the test policy and strategy for the organization, coordinate the plan with project managers and others, so contribute to the testing perspective to other projects activities such as development, integration, and implementation. Plan the tests, including selecting test approaches, estimating the time, effort, and cost of testing, acquiring resources, defining test levels, cycles, and planning incident management. Assesses the test objectives, context, and risks. Initiate the specification, preparation, implementation, and the execution of tests. Monitor the test results and check the exit criteria. Adapt planning based on the test results and progress and take any action necessary to compensate for problems. Set up adequate configuration management of testware for traceability. Introduce suitable metrics for measuring test progress and evaluating the quality of the testing and the product. Decide what should be automated, to what degree and how. Select tools to support testing and organize any training in tool used for testers, and supervise the implementation of the test environment, and write test summary reports based on the information gathered during testing. Tasks of the tester. So testers or test analysts who work on the test analysis, test design, specific test types, or testing automation may be specialists in these roles. So depending on the test level and the risks related to the product and the project, different people may take over the role of tester, keeping some degree of independence. So typically tester at the component and the integration level would be developers, and the testers at the acceptance test level would be included business experts and users, and testers for the operational acceptance test might be operators or system administrators. So a typical tester task may include review and contribute to test plans, analyze and review user requirements, specifications and models for testability, create test specifications, set up the test environment with appropriate technical support, prepare and acquire test data, implement tests on all test levels, execute and log tests, evaluate results and record incidents, use test tools as necessary and automate tests, measure performance of systems as necessary, and finally review tests developed by others. In this part, we're gonna talk about the planning and the estimation, and it's gonna be quite a bit of text, but bear with me. The objectives of learning in this part, it's planning activities. So the objectives is recognize the different levels of objectives on testing planning. Summarize the purpose of and content of the test plan, test design specification, and test procedure documents according to the standards of software test documentation IEEE standard 829 from 1998. differentiate between conceptually different test approaches, such as analytical, model-based, methodical, process standard compliant, dynamic, heuristic, consultative, and regression averse. Differentiate between the subjects of test planning for system and scheduling test execution. Write a test execution schedule for a given set of test cases, considering prioritization and technical and logical dependencies. List test preparation and execution activities that should be considered during test planning. Recall typical factors that influence the effort related to testing. Differentiate between two conceptually different estimation approaches, the metrics-based approach and the expert-based approach. And finally, you will learn about recognize, justify adequate entry and exit criteria for specific test levels and groups of test cases for integration testing, acceptance testing, or test cases for usability testing. So moving on into the planning activity. So test planning and estimation is a breakdown of the planning and control phase of the fundamental test process discussed in chapter 1, the section 1. It outlines the purpose of test planning within the development and the implementation projects and the maintenance activities. So test planning is a continuous activity and is performed in all life cycle process and activities. And I mean, the actual breaking down the planning activities is the first test activity to be carried out at the each test level, but it is a continuous process and is performed throughout the life cycle. Feedback from test activities is used to recognize changing risks so that the planning can be adjusted. So planning is a lot more than scheduling. It may also include determining the scope and risks and identify the objectivities of testing, defining the overall approach to testing, including definition of the test levels and entry and exit criteria, linking into other software lifecycle activities such as acquisition, development, operation, and maintenance, assigning resources for the different activities defined, deciding testing tasks, roles, schedule, and evaluation of test results. So defining the amount, level of detail, structure, and template for the test documentation, selecting metrics for monitoring and controlling testing, and finally, setting the level of detail for the test procedures. Levels of planning. So test planning may be documented in a hierarchy of documents, each one defining the approach taken to testing projects within an organization. So here's divided in three: test policy, test strategy, and test plan. So the test policy, a document characterizing the organization's philosophy towards software testing. It is set at the highest level of the organization, and it is overall approach to quality assurance, giving general guidelines for all project testing. It may be the IT department's philosophy if there is no organization, document. So the test strategy, it's quote a high level description of the test level to be performed and the testing within those levels for an organization or program. A division or program sets out the testing strategy based on the test policy and identify the risks. So there are two main aspects: risk to be resolved by testing the software and a testing approach used to address the risk. And the test plan, it's a quote, a document describing the scope, approach, resources, and the schedule of the intended tested activities. So each project adapts the strategy to create a test plan for that particular project. So here's a graphical hierarchy of the planning. So like I mentioned before, so there's a test policy, the test strategy, and then the master plan. And under the master plan, for the project itself, so there's a component test plan specific for the components when it gets to that point, and then moving on to the integration component, and then the system testing test plan, and then the acceptance test plan. So it's all a part of the planning. So there might be further plans for test levels like maintenance testing, regression testing, static testing, etc. But I'm not showing in here. Levels of planning according to IEEE 829 1998. So it's standard for software development documentation. So most businesses adopt the IEEE standard 829.1998 test plan outlining for documented test planning, but even the standard it's not being using, the approach to test planning should be more or less the same. So the new standard for 8 to 9, it's actually the ISO IEC IEEE 29119. But for the ISTQB exam, learning 8 to 9 should be sufficient, at least for now, until they update with the new standards. But for now, you should be okay to learn that 8 to 9 to be able to pass at the foundation level exam. Um, so in the next slide, I'm gonna be showing you the test plan contents for the next slide. But before I move on, so here's something to help you memorize what are the table that I use to go through the plan. So I got this from someone who worked before, a well experienced guy, like 20 years in testing. So little something to help you memorize all these is space dirt. So S for scope, P for people, A for approach, C for criteria, E for environment needs, D for deliverable test, I for identify and introduction, R for risks and contingencies, and T for testing tasks and schedule. This is just like something for you to remember while you're doing the exam. I found it quite useful. So moving on. So the test plan content. This is a table. There's a bit more there, so I couldn't fit in one slide. So the IEEE triple E 829 test plan content. It's as shown here. So the test plan content, the test plan identifier, you should start off with a unique ID. So like a number for when you can refer it back and you can easily identify and find it. So then moving on into introduction, execute summary and background. Test items, so is a list of software modules that you're going to be testing, the features to be tested, so application functionalities and all the functions and of the software. So the features not to be tested, so out of scope, together with the features to be tested, define scope of testing. So the approach, so how is going to be the approach for testing. So from the test strategy modified for projects, so analytical, preventive, reactive. So it depends on how you're going to approach. So the column for to determine how, if it has passed and failed, so the criteria for that. So strictly this is the criteria for deciding if a test passes or fail, but it's usually used for entry and the exit criteria. So the suspension criteria and the resumption requirements. So the circumstances that would prevent testing from continuing such as extremely poor quality software. And continuing with the test plan, the test deliverables, so the standards for test specifications like logs, incident reports, etc. testing tasks, any specialized task not covered in the approach. So environmental needs, so you need, software, data, hardware, network, software licenses, everything that you need to be able to carry on with the test. So responsibilities, who manage testing, risks, incidents, reporting, training, etc. So staffing and training needs. So training in test skills or tools for testers and users involved in testing. So you might find that you need to give some more instructions for juniors or for other people in the business that are not testers. You need to show them where they to get to things and how they go through the tests. So the schedule, so the timetables, the milestones, delivered dates based on estimation strategy. This is going to be working, with PMs, your project managers. So risks and contingencies, so project and product risks and workarounds in case of failures, and I'm sure this will happen. And approvals, so who has the authority to sign off these and other testing documents. This is quite important as well, to sign off the testing in each phase that you move along. Entry criteria. Entry criteria define when to start testing, such as the beginning of a test level or when a set of tests is ready for execution. So typically, entry criteria might include a test environment available and ready, test tool configured in the test environment, testable code available, test data available, including configuration data, logins, etc. Test summary report or evidence available from previous testing, including quality and coverage measures. Third-party software delivered and software license bought. Other project dependencies in place. So entry criteria for one test level might match the exit criteria of the previous levels. For example, the entry criteria, 80% of system tests completed for entry criteria for UAT, user acceptance testing. Unit testing is completed with branch covered reports, which is for an entry to system testing, and all documentation is present and has been signed off. Exit criteria. The exit criteria define when to stop testing at the end of a test level or when a set of tests has a specific goal. So this decision should be based on a measure of software quality achieved as a result of testing rather than just one time spent on testing. So typically exit criteria may consist of measures of testing thoroughness, for example, coverage of code, requirements, functionalities, or risk, estimate of defect density or reliability, cost, so residual risks such as a number of defects outstanding or requirement not tested, schedules such as those based on time to market. Typical example might be all paths covered of code, high and medium risks areas completed, no outstanding high severity incidents, all security testing completed successfully, and exit criteria may differ greatly between different levels. For example, coverage of code for component testing, coverage of requirements or risk for system testing, non-functional measures such as usability in acceptance testing. Test approaches. The test approach should be set out in the test strategy, then refined and implemented in test plans and test designs for a specific project. It is the starting point for planning test activities, choosing the test design techniques and defining entry and exit criteria. So test approaches might be Preventive, where tests are designed as early as possible. Reactive, where the test designs comes after the software has been produced. Typical test approaches include analytical approaches such as risk-based testing, where testing is directed to areas of greater risk. Model-based approaches such as stochastic testing using statistical information about failure rates, such as reliability growth models, or usage such as operational profiles. Methodical approaches such as failure-based, including error guessing and fault attacks, checklist-based, and quality characteristic-based. The process or standard compliant approaches, such as those specified by industry's specific standards or the various agile methodologies. Dynamic and heuristic approach, such as exploratory testing, where testing is more reactive to events than pre-planned, and where execution and evaluation are concurrent tasks. Consultative approaches, such as those where test coverage is driven primarily by the advice and guidance of technology and or business domain expert outside the test team. And regression-averse approaches, such as those that include reuse of existing test material, extensive automation of functional regression tests, and standard test suites. Um, Choosing an approach is so different approaches might be combined. For example, a risk-based dynamic approach. The selection of an approach depends on context, risks, hazards, safety and regulations, available resources and skills, testing objectives, types of system and technologies. Test estimating. Test managers need to estimate the time, effort, and cost of testing tasks in order to plan test activities, identify resources requirements, and draw up a schedule. Two possible approaches are the metrics-based approach, so based on analysis of similar projects or on typical values, and the expert-based approach, based on assessment by the owner of the tasks or domain experts. So how long will this testing take and how much will it cost? Metrics-based estimation example. So based on a standard percentages using a work distribution model. So testing is notorious more difficult to test than other project activities, such as requirements analysis and development. Standard percentages uses industry or company-based historical data to calculate the proportion of time to the testing stage take for different project types. Then if you can size the overall project, you can work out how much testing effort is required without estimating the test task directly. So alternatively, if you can obtain more accurate estimates for a non-testing part of the project, you can apply the appropriate proportions. For example, using this figure here, which is not official by the way, if the development manager provides an estimate of 40 days for coding and unit testing, then that is equivalent to more or less 60% of the total development and testing time. So system and integration testing, roughly 25%, and it would take 17 days, and acceptance testing about 15% is about 10 days. So obviously not all projects are the same. So for example, like a package purchase would require integration and acceptance rather than just unit testing. Expert-based estimation example. So based on a microestimate using work breakdown structure. So experiences is still the most widely used approach. Asking the task owner means they are more likely to commit to a deadline and also think through every details of the job. For example, remembering about setting up test data, etc. So breaking a large task into bite-sized chunks make it easier to understand and leads to more accurate estimate. So in this table here, as an example, uh, so a task is read a functional specification, about 2 days, identify functions to test, 1 day, uh, attend walkthroughs, 1 day, define test conditions, 3 days, write test cases and scripts, about 5 days, determine the test date, about 2 days, and setting up the environment, 1 day. So that gives you an estimate of a 15 days worth. So here are the factors to consider when estimating. The testing effort may depend on a number of factors, including um, product factors such as the quality of the specification, size and complexity of the product, and requirements for reliability, security, and documentation. Development process factors and the stability of the organization, tools used, the test process, the skills of the people involved, and time pressure. So quality factors, for example, the number of defects and the amount of rework required. So functionality forms the core approach to estimating, but all sorts of environmental factors come into play too. So rework is a major consideration. Filling incident reports, retesting, changing documents can take an equivalent time to the initial tests. Moving on into test progress monitoring, and gonna talk about control as well further on. So the objectives to the learning here is recall common metrics used to for monitoring test preparation and execution. Explain and compare test metrics for test reporting and test control. For example, defects found and fixed, and tests passed and failed. So related to purpose and use. So, and also summarize the purpose and content of the test summary report document according to the standard for software test documentation, the IEEE 829. So the test progress monitor, so is a throughout a project, the progress of test activities should be monitored and checked frequently in order to provide feedback and visibility about testing to stakeholders and managers, assess progress against estimated schedule and budget in the test plan, measure testing qualities such as a number of defects or coverage achieved against the exit criteria, assesses the effectiveness of the test approach with the respect of objectives, collected data for future project estimation. So the metrics used to measure progress should, if possible, be based on objective data. For example, numerical analysis of test activity rather than subjective opinion. These metrics may be collected manually or automatically using test tools such as test management tools, execution tools, or defect trackers. So the test manager may have to report on deviation from the test plan, such as running out of time before completion of criteria it is achieved. Um, So the metrics include percentage of work done in test case and the environment preparation, test case execution, number of test cases run, not run, test cases passed or failed, defect information, defect density, defects found and fixed, failure rate and retest results, coverage of requirements, risks, code, dates of tests, milestones, testing costs, including the cost compared to the benefit of finding the next defect or to run the next test. The best metrics are those that match the exit criteria, for example, coverage, risk, and the defect data and estimates time and cost defined in the test plan. Typical progress metrics. So plotting a graph using a test planning tool or spreadsheet is a great way to monitor test activity against the plan. The graph below is a typical and allows test managers to check that the number of tests passed does not diverge too far from the number executed. So it's always good to use something to measure the goal and the progress and where you are. So to yourself and the test manager and the other stakeholders. So this is something that you're gonna see while you're working on tests. Number of incident reports. So other graph common used by test managers is to show how fast incidents are dealt with as they are raised. If the lines do not start to converge towards the end of the project, test managers can take appropriate actions such as adding more resources to fixes or addressing quality problems. So this is a graph that the test manager or the team manager would be looking at the number of incident reports and the time length. So so this is the two lines with the incident reports against the closed incident reports. Test control. If test monitor shows that the progress is slipping from the planned targets or the exit criteria are not being met, then test managers may have to take some guiding or control actions to get back on track. So options for actions may often be limited, but might include reprioritize testing activities, for example, focus testing on higher risk objectives, change test schedule, for example, allocate more time to testing, reassign resources, for example, assign more testers or more developers working on fixes, set entry criteria for deliverables from developers, for example, set minimum quality level at the start of testing, and adjust exit criteria, for example, reassesses acceptable quality measures. Test reporting. Test managers will report regularly on the test progress to project managers, project sponsors, and other stakeholders. The report should be a summary of test endeavor, including what testing actually occurred, statistics on key metrics, and the dates on which milestones were met. So reports will be based on metrics collected from testers and may be consolidated using spreadsheets or test management tools. It is then analyzed by project stakeholders to support recommendations and decisions about future actions. So, assessment of defects remaining, economic benefits of continued testing, outstanding risks, level of confidence in tested software, effectiveness of objectives, approach, and tests. Here's an example of a test summary report. So the test summary report is a part of the IEEE standard 829-19998 and is used to summarize test activity at the end of a test level. The outline of the standard report is as shown below. So the report item, the summary, it's the what was tested includes software items and versions, test environment, and the references to other documents such as test plans, logs, and incident reports. So variances are the changes from the plan or test specifications, such as a test is not followed as per plan, and the tests performed in addition to the plan. So comprehensiveness assessment is the assessment of the test processes describing features not testing and reasons. Summary of results, so higher level description of incidents, fixes, outstanding issues, and state of resolution. Evaluation is the assessment of software quality and estimate of software reliability and failure risk. And finally, the summary of activities, so details of the test processes, such as elapsed time, cost, resources, and personnel used. Configuration management. The purpose of configuration management is to establish and maintain the integrity of system products throughout the project life cycle. It applies to all products connected with software development, such as software components, data and documentation, and testing, such as test plans, test specs, test procedure, and test environments. Configuration management is therefore more than just version control. It's also about knowing what version are deployed in different environments at different times. It ensures that every item of testware, software, and test documentation is uniquely identified, version controlled, tracked for changes, related to each other, and related to the development items. Although these items may be physically stored in many locations, configuration management describes and links them in a common controlled library. This ensures that all identified documents and software items are referenced unambiguously in test documentation, which avoids tests being run against the wrong software version. Risk and testing. So testing involves the analysis of a risk of something that could may and happen with the software. So a tip of advice, I would say, whenever you see the word risk within the answers A, B, C, and D within the exam, uh, just think about the word risk. So to me, in my experience with the exam, the word risk would be most of the time more likely to be the right answer. So just bear this in mind. So risk is a very important word in testing. So in this part, I'm going to be discussing more like describing a risk as a possible problem that would threaten the achievement of one or more stakeholders or project objectivities. Uh, the idea to talk about that is so you remember that the level of risk is determined by the likelihood of something happen and maybe an impact harm resulting if it does happen. So distinguish between the project and the product risks, recognize typical product and project risks, describe using examples how risk analysis and risk management may be used for test planning. So moving on, risk-based testing is seen as the best approach to enabling the best testing to be done in the time available. In this section, we're going to be cover measuring, categorizing, and managing risk in relation to testing. So, according to ISTQB, quote, the risk is defined as the likelihood or the impact. So, the quote by ISTQB is a factor that could result in future negative consequences, usually expressed as impact and likelihood. So a risk is a specific event which would cause problem if it occurred. Individual risk can be assessed in terms of likelihood, so the probability of the event, hazard, or situation occurring, and the impact, the undesirable consequences if it happens. For example, financial, rework, embarrassment, legal, safety, or the image of the company. So we're going to be talking in the next slide. So there's two types of risks. So there's a project risk and the product risk. So what is project risks? Project risks are the risks that affect the project or test team's capability to deliver its objectives, such as technical issues, so problems in defining the right requirements, the extent that requirements can be met given existing constraints, test environment not ready on time, poor quality of design, code, or tests, late data conversion or migration planning. Um, Organizational factors could be the skill, training, and staff shortages, personnel issues, political issues such as problem with testers communication their needs and test results, or failure to follow up on information found in testing and reviews, unrealistic expectations of testing, and supply issues. So it could be a failure of a third part, contractual issues. Product risks. So product means the software or system. Potential failures in this software are known as product risks, as they are a risk to the quality of the system. So product risks include failure-prone software delivered, potential for software or hardware to cause harm to an individual or a company, poor software characteristics, so like functionality, reliability, usability, or performance, uh, poor data integrity and quality. So, for example, data migration issues, data conversion problems, data standards violation. So, it means as well as software does not work as intended. So, this is a product risk. Risk assessment matrix. So, for each risk identified, its likelihood and the impact must be assessed. These may be numerical measures like 1 to 10 or simply low, medium, and high. Combining likelihood and impact measures into an overall risk measurement allows risk from different areas to be compared, assessed, and prioritized. So risk and their assessment should be recorded in the test plan, perhaps using a matrix similar to this. So as you can see on this one, we have the function, the risk is a capture customer details. So the likelihood of failure is marked as a median. So the reasons of that, it's a human error or under pressure. So the impact of failure, medium, the reasons is a limited checking, and the overall risk is medium. And moving on to two is a print customer details. So a likelihood of failure, low. It's a simple program, no human intervention. So the impact of failure is medium. So the reasons is embarrassment if customer contacted with wrong details. So the overall risk is a medium low. And the third example here of a function is send customer details. So the likelihood of a failure is medium. So the reason of that is a new technology for network, part of a used package. And the impact of failure is high. The reasons is a customer billed incorrectly, bill sent to wrong address. So the overall risk of this function is a median high. So once a risk has been assessed, there are two possible actions which can be put in place to reduce the risk. Mitigation, which is a preventive or a proactive action to reduce the likelihood of the risk happening, and a contingency, it's an emergency or reactive approach to reduce the impact if the risk happens. So risk-based testing. So a risk-based approach to testing provides proactive opportunities to reduce the levels of product risk, starting in the initial stages of a project. It involves the identification of product risks and they using guiding test planning and control, specification, preparation, and execution of tests. So risk-based testing draws on the collective knowledge and insights of the project stakeholders to determine the risks and the levels of testing required to address those risks. For example, developers can identify the most complex code, users may describe the most used functions, manager may highlight the areas with the biggest financial impact, and etc. In a risk-based approach, the risks identified might be used to determine the test techniques to be employed. For example, white box testing for safety critical system, usability testing for customers input screen, security testing for e-commerce system. So, and the other one is determine the extent of testing to be carried out. For example, what to test and not to test, what to test first and last, and what to test most and least. And also prioritize testing in an attempt to find the critical defect as early as possible. For example, use a traceability matrix to link test design to priority requirements. Create test execution schedule to run tests in the most efficient order, and focus on defect clusters. And lastly, determine whether any non-testers activities could be employed to reduce risks. For example, provide training to inexperienced designers or improve documentation. So in addition, testing may support the identification of new risks, help to determine what risks should be reduced, and lower uncertainty about risks. Incident management. An incident is any unplanned event that requires further investigation. During test execution, discrepancies between actual and expected results are logged as incident and must be investigated. Incidents may be raised as at any time throughout the software development lifecycle against documentation during static testing, as well as code or a system under test. It is important that business should have an incident management process to track incidents from discovery and classification to correction and confirmation of solution and finally closure. Systems management standards often reserve the term incident only for production faults. Causes of incidents. Testers tend to assume that all failures are caused by a defect in the software, but there are many possible causes. Software defect, requirement or specification defect, environment problem, for example, hardware or operating system or network, fault in the test procedure or script, for example, incorrect, ambiguous, or missing step, incorrect test data, incorrect expected results, and tester's error, for example, not following the procedure correctly. Test incident reports. Incidents must be recorded in incident reports, either manually or using an incident management tool. There are many reasons for reporting incidents, including provide feedback to enable developers and other parties to identify, isolate, and correct defects, enable test leaders to track the quality of the system and the progress of testing, provide ideas for test process improvement, identify defect clusters, maintain a history of defects and their resolutions, supply metrics for assessing exit criteria. Here's an example of the test incident report based on the IEEE standards 829. So the section would include something like the report item, which is a report identifier. The description says a unique reference for each incident. So the summary would be the summary of circumstances in which the incident occurred, referring to software item and versions, test case, test procedure, and test log. And the description is the incident in details, including the input, the expected and actual results, anomalies, time and date, environment, attempt to repeat, for example, steps to reproduce, testers and observes the comments of a tester while you observing what happened, and the impact, so the identification of what impact this incident will have on the progress of testing. So most organizations find the IEEE 829 standard is not detailed enough for their needs and find it useful to include further details such as severity, so the level of importance to the business or project requirements, the priority, so the impact of the testing process and the urgency to fix, status, progress of incident resolution, for example, open, awaiting fix, fixed, deferred, awaiting retest, or closed. Other areas that may be affected by a change resulting from the incident, actions taken by the project team member to isolate, repair, and confirm the incident as fixed, and system lifecycle process in which the incident was observed, and the change history. So there are different views on the use of the priority and severity measure. For example, the severity equals the impact on functioning of the system. Priority, how quickly the business is required to fix, and or severity, impact of failure, and priority, likelihood of failure. So whatever definitions are used, every test organization should have clear guidelines on the use. Some organizations have incident measures independently accessed by the manager or defect manager. Test incident lifecycle. The incident or bug lifecycle is managed to use the status measure on the incident report. Possible status values are open, assigned, deferred, duplicate, waiting to be fixed, fixed awaiting retest, closed, reopen, etc. Other status values might indicate that the bug is a pre-existing production defect, that the system works as is specified, or that the defect has already been recorded. If retesting shows that the defect has not been successfully removed by the developer, the incident report may be reopened rather than being closed. So here's a typical cycle. So report incident, the tester prioritize and assign, so the test manager or the manager looking after the testers, debug, fix, and check by the developer. And then once it's done and fixed, then the developer assigned to tester again. So the actual tester who opened the incident or the bug can retest and close. Okay, well done. So we come to the end of the section 5. So here's a summary of what you learned so far. So we talked about mainly around risk. So risk, level of risk, project risk, product risk, risk-based testing, and risk-based approach. So testers and the test lead, what they do, what are their tasks, the master plan, and we talked about all the other plans as well and the definitions. We talked about mainly about the IEEE 829, and I already mentioned that there's a new standard, the 29119. But once you learn 829 is sufficient for you to pass the exam right now. There's no changes yet from the ISTQB in terms of around that. The test planning activities, defining entry and exit criteria, test estimation, and test control. Okay, well done. So you complete the section 5, which is really good. So now it's just one more to go. So in the meantime, before you go, go to the last section. I know you wanted to complete. Do the quiz. It's good if you go through the quiz now, because the your memory is still fresh from the things you just saying it. And don't forget, before you go, leave any questions if you have any questions in a particular key point on these section 5. If you have any comments that helped me improve it, please do so. And if you really like it, just thumbs up. Share with your friends, share with your colleagues, and that's it. So let's go to the last section, section 6.